for another lecture video, this time section 7.3. Once again, I am Dr. Scott Spaniel, your instructor for statistics at Morton College. So today what we're going to talk about is what's called assessing normality. So we're going to be, in the chapters to come, we're going to be using the stuff we talked about in the last section to calculate probabilities from given samples. But in order to use that, we need to know, is the sample data normal? And so if we aren't given that information, we need a way to find out. And the way we find out is by using the stuff that we're going to learn in this section. So if you take out your chapter 7 note sheets and turn to page 16, we can talk about assessing normality. So a normal probability plot is a graph that plots observed data versus normal scores. So the idea is it plots the data you get in your sample versus what you would expect the data value to be if it were a normal, if this data was normal. So a normal score is the expected z-score of the data value, assuming that the distribution of the random variable is normal. So it basically takes the z-score that the data value has based on the mean and standard deviation and compares that to what it should be if the data was normal. If sample data are taken from a population that is normally distributed, a normal probability plot of the observed values versus the expected z-scores will be approximately, and this isn't right, approximately linear. Okay, so the normal probability plot should make approximately a straight line. So here are some ones from a program called Minitab, and we just want to decide whether these are normal or not. For the most part in Minitab, it should make basically a straight line, but also all the data values should fall between these blue lines, the most extreme blue lines. And if it were exactly normal, it would fall on this middle blue line. So if we look at the first one, if you try to kind of trace what it's doing here, let me use a different color than red. Right, if you're trying to trace what the graph is doing, is that approximately a straight line? No. And it didn't fall, so this would be not normal. Okay? So that's all we're doing here with these, is trying to decide, does this make basically a straight line? Or do they fall in here? And here, this one kind of goes like this, but that's relatively straight, right? It's not exactly straight, but it's fairly straight, so we could say that that is approximately normal. And then the last one here, you can see, kind of makes an S. So is that approximately linear? No. So this is not approximately normal. So in the first and last example, if those were my sample data, I would not be able to use the stuff I just learned about in section 7.2 to find probabilities for that data set. In this middle one, I would be able to use things like normal CDF and the area under the normal curve to find probabilities. So what I'd like you to do is flip over to the next page, pause the video for a moment, and decide which, if any of these, are approximately normal. Okay, now you've had a chance to look at them, let's go through them together. So this first one, you can kind of see makes kind of a weird shape, but it definitely falls outside that blue line, so this would be not approximately normal. Right? The middle one, all of that falls within the blue line, so that would be approximately normal. And it follows a fairly straight line. And then the last one too, all of it falls within the blue. It's a little less, it's a little more, but it's still all within the blue, so that would be approximately normal. So that's one thing. You need to be able to read these normal probability plots when they're given to you, but you also need to be able to do them, because when we're doing problems in later chapters, most likely you're going to have to do the normal probability plot yourself. So if you flip over to the next page, we can practice that. So use the normal probability plot to assess whether the sample data could have come from a population that is normally distributed. So a random sample of weekly work logs at an automobile repair station was obtained, and the average number of customers per day was recorded, which is listed here. So we can do this using ClassCalc. So I have this data in your data sheets. So in the note sheets, data sets, Google Sheet, 7.3 problem 1. So if I copy and paste the data, which is the same as what's in your note sheet, so you could also just type it in, to a list in your graphing calculator, and I paste it over here. Right, and I like to, you can leave the name as x sub 1, but then you have to type in x sub 1, so I like to change this to something like a. And if you go into stat, distribution, and plot, you'll see that the last one on the bottom left is normal probability plot. So if you choose that, and you put in list A, and you zoom in, it should give you a normal probability plot and tell you how approximately linear. And this one looks fairly linear. I'll also tell you, we're going to talk about this in more detail, and this is one of the downsides of doing Chapter 4 at the end because we talked about this, but this number right here, this R value, the closer to 1 that is, the more linear this data is. So in this case, this is an R value very, very close to 1, so we could say that this is approximately normal. Okay? Because it looks approximately normal and because we have an R value. And we're going to talk more about R values when we do Chapter 4 at the end of the course. But for now, the key is to know, for doing normal probability plots, all you really need to know is this close to 1? And this is close to 1. Okay, that's all you need to know for now. So what I'd like y'all to do now is you could pause, take the data that's in our data set thing, or type this in. Don't you type in the commas, remember. But you could try this on your own, and then we'll go through it together. So take a moment, pause the video, and try that. Okay, so now that you've had a chance to try it, let's go ahead and work on this together. So I'm going to just get rid of the data from the problem we just did. I'll go into my node sheets data. It's under problem 2 in 7.3. I will copy my data, go into ClassCalc, paste my data, and then I'm going to choose stat, distribution plot, normal probability plot. Oh, I left that one alone, so I'm going to do x sub 1, but you can change the name. And if we zoom in on this one you can see that this is not approximately linear, right? It does not have a linear shape. And the R value is not as close to 1. It's not in the 9s, okay? And if you want, you can change that. If you hit that, just so you know, it just changes which axis you're on. This is best to leave it on the X. It gives a better graph. Like that. But there is your graph. So that one, it was not approximately linear, right? R was less than 0.9. So this is not approximately normal. Okay. So that's the idea there. So if this value is not above 0.9, then you're not going to be able to say these are approximately normal. Okay. So that's it for section 7.3. That's a pretty straightforward and short section. It's just the one last skill we needed to go over in chapter 7. At this point in the course, we're done talking about probability, and we're going to start moving into inferential statistics and how to use probability. So don't forget to take your test over chapters 5, 6, and 7. And if you have any questions, feel free to send me a message on Remind or by email, and I'll get back to you as soon as I can. And I will see you all next time for our first chapter 8 video.